Hi everyone, we're going to find the radius of the circle and the area of the sector given that our sector has an arc length of 6 feet and a central angle of 1.2 radians. So the first thing we're going to do is let's go ahead and do the find the radius of the circle. So we're going to use our arc length part, which equals S equals R times your angle. Remember, your angle must be in radians. So basically, we already were given it in radians. So basically, we know that our arc length is 6 equals R times 1.2. And so divide both sides by 1.2, and you got R is 5, which would be 5 feet. Alright, and then so part B wants to find the area. So the area is 1/2 R squared times your angle. So your area is 1/2 times 5 squared times 1.2, which equals 15 feet squared. Okay, next problem is very similar. We're finding the radius of the circle and the area of the sector. And this time they gave us the angle, central angle, as 135 degrees. So when you convert this to radians, or you should know from your unit circle that this is 3 pi over 4. Again, you're just taking 135 times pi over 180, which will give you 3 pi over 4. So we're going to first use S equals R times theta, and our S is our arc length, which is 114 millimeters. Our R is what we're looking for, and our angle is 3 pi over 4. Solve for R, and you get R is approximately, if you round to the nearest tenth, 48.4 millimeters. And our area, the second part, is going to be 1/2 R squared times your angle in radians, which is 1/2 48.4 squared times 3 pi over 4, which is approximately 2,757.8 millimeters squared. Okay, we have two more problems. We want to find the radius of the circle. They already gave it to us in radians, and the arc length of the sector. So the first thing we're going to do is use our area formula, since we can get our R from that. So we have our area is 15, and then we have 1/2 R squared times 0.2. Multiply both sides by 2 and divide by 0.2, and you get 150 equals R squared. And when you square root both sides, and R is always positive, you're going to get 12.247, which is about 12.2 inches if you round to the nearest tenth. So we found our R. Check. Now to find the arc length, we use our arc length formula. Remember, our angle is in radians. So we have S is approximately 12.2 times 0.2 radians, which is approximately 2.4 inches. Okay, and the last one, we have to find three things. So the first thing I want to do is I have to find the radian measure. The radius of the circle is 3. So we have the radius and we have the area. And so we have to find the radian measure. So I'm going to use my my area formula to find the radians, like I did in the previous one. So 15.3 equals 1/2 times 3 squared times your angle. This is what we're looking for. So this is 9/2 and divide. So you get 3.4 equals your angle in radians. All right. Now we have to find it in degrees. So we take 3.4 times 180 over pi. So we did that. Now we're doing the degree, and we're just converting basically. And you get approximately 194.8 degrees. And then find the arc length. All we're going to do is use our formula. Arc length formula is r times theta. So r is, let's see, r is 2. Let's see, am I on the right one? So we have 3.4 equals okay, wait. So that's 194. And then we're going to do S. Sorry about that. I was doing the same thing. So your S equals 3 times 3.4. Using your 3 meters for the radius. And that's going to give you 10.2 meters. And that's all. Thank you. Have a nice day. Bye-bye.